So to talk about this project, this is the patient which would be working on, and he would be undergoing a head surgery. So this is the location of the actual head surgery being carried out, and this has been magnified for a larger size as per this diagram, which is this plate represents the actual head part of this portion which is gonna get operated. So in this we'll be making use of an end effector and also the help of a spreader, and this entire mechanism is operated by the 5-axis motion. So these are all the supports, the 4 supports, 1, 2, 3, and this is the 4th one over here, and this guides the movement of the end effector. As you can see, now it's moving towards the left, and once it reaches its extreme, now it's moving towards the right. Now this end effector comprises of 2 tools, of which one is the cutting tool, which you can see over here, and this one is the drilling tool, which will actually drill into the head to perform the operations. As you can see, the 5-axis motion, now the end effector is coming in the forward direction, and similarly it will go back in the backward direction, and at the same time moving towards the right. That means it takes 2 motions into account simultaneously. Now along with this end effector we have the spreader. So in this we have the 2 spreader mechanisms, one over here and the other one is this, which would help in moving the spreader forward and backwards such that it would insert this portion into the peeled off part of the brain and then move it back, thereby increasing the area of the operation. Now in this, as described, the end effector has moved by about 90 degrees. It can actually have a rotational motion up to 180 degrees, but depending on our operation it has moved 90 degrees. Now this drilling action would go vertically downwards to drill into the skull and then relieve the pressure of the blood clot, and then once the operation is done, the drill stops, the end effector moves upwards, and then again it's rotated back to its initial position. Now also the cut can be easily seen with the help of the camera, which is fitted over here. So once the end effector takes up the positioning above this surface, it can easily capture the cut or inspect the cut, and it can be presented on the monitor as well.
This is our robotic surgery platform. The 5-axis motion stage allows the precise positioning of the end effector in order to perform various functions. As you can see, we will be doing brain surgery on a scaled down model, which is represented full scale under our spreading assembly stage, which allows for lifting off the skin before drilling through the bone in the scalpel. This end effector is controlled by this control box. Inside the control box we will find a power supply unit, an Arduino microprocessor, various DC stepper drivers, and other sensors.